Today we will discuss a mechanics and materials unit called the MTP. It has been designed to show vertical and rotational displacement in bending and torsion.
Here's the MTP twist and bend test unit. The structure consists of an aluminum base and two steel guides, along which adjustable steel supports move. A knob on the back of the support tightens them down onto the steel guides. There are two torsional clamps. One has a bearing and an attached torsional loading arm to apply twist to a circular cross-section rod. There is a dial indicator with rotating face and three knobs to adjust the position of the device on a sample. There are 6 weights, 2 10 Newton and 4 5 Newton, a weight holder for bending, and a weight holder for torsion.
There's also a provided Allen key.
There are also 7 steel rectangular cross-section bars and 4 circular cross-section samples, 1 copper, 1 steel, 1 aluminum, 1 brass. Now we will demonstrate some of the possible practical exercises. First, bending exercise with a rectangular cross-section sample. Place a rectangular cross-section sample on the steel supports. Next, position the dial indicator so as to press approximately 10 millimeters to allow for a sufficient range of downward deflection. Once the weight holder is applied, make sure the dial indicator is zeroed by adjusting the rotating face so that the arm points to 0. Then, add weights to the weight holder to apply a loading to the sample. Recording the deflection of the sample, we can continue to add weights and measure the deflection in order to observe the effect of loading on the deflection. This bending test can also be done with a circular cross-section rod. The sample's different geometry is accounted for in the moment of inertia in the deflection equation. Again, make sure the dial indicator is positioned on top of the sample and compressed approximately 10 millimeters to allow for sufficient range of measurement. Add the weight holder to the sample, zero the dial by rotating the face, then add weights to measure and record the deflection. The span is also adjustable by moving the steel supports along the steel rails. The effect of changes in span can then be observed as well. Additionally, the effect of the sample's dimensions can be determined by performing the test with samples of different dimensions. Now we will demonstrate a torsion exercise. This is carried out with a circular cross-section rods because rectangular and circular cross-sections behave drastically different in torsion. We place a sample in the torsional clamps and tighten down the 4 screws with the provided Allen key. And make sure the clamp on the side of the torsional arm is tightened down with the torsional arm at about 90 degrees from the vertical. The arm can be tightened and loosened separately from the clamp. Additionally, the clamping distance is adjustable by sliding the steel supports along the steel guides. Move the dial indicator down to the end of the apparatus with the torsional loading arm. Then adjust the dial indicator so that it is compressed approximately 10 millimeters and so the end of the dial rests on the groove in the torsional arm. By assuring the dial indicator is placed at this position, based on the dimensions of the apparatus, every 1 millimeter of downward deflection corresponds to a 1 degree rotation of the sample. Then, add the torsional weight holder and adjust the dial indicator so the arm points to 0. Add weights to apply a loading and measure the deflection. Record the rotation at different loads and determine the relationship of rotation to loading. Also, we can adjust the clamping distance and determine the relationship of clamping distance to rotation.
Finally, every unit comes with a 3-year guarantee and complete component control. Due to these features, we guarantee full customer satisfaction. Thank you for watching this video. You can find a link below to our website. For more info, please contact us by phone or email. We look forward to talking with you.